Well, here we are. If you could please go back to your seats. We now have two exceptional speakers. I'm sure you know at least one of them. They've been asking me to allocate 55 minutes and ensure that that time is available. So please introduce yourselves. Thank you very much. Thank you for being here. My name is Alfonso. I guess that some of you know about me. I've come here with Miguel. So these are our contact details, Twitter accounts, and everything. We've come here today to tell you about a very peculiar type of research that was conducted about this world that has become so fashionable. Artificial intelligence, its application to security, with all the technologies that exist in that environment. We'll talk about security in graph databases. We'll tell you what they are, why they are useful, and tell you how security is in this type of technologies. We'll tell you about the most famous databases and tell you about the types of attacks that you may encounter. We'll see a number of demos throughout our talk. Some of them are relatively complicated, so we've done some shooting, video shooting. On some others we cannot perform over the internet for legal reasons, so you'll see a number of video clips. So we'll do our best to try and prevent getting into prison today. This is, well, contact details, things we do. Well, Miguel is a telecommunication engineer with a master's degree in cybersecurity. He loves city apps. He's got prizes and awards all over the place in different hackathons. You've got the information. So, the talk. What are we going to talk about? First of all, we'll tell you about graph databases. We'll also talk a little bit about machine learning, but just a little bit, to let you know how to apply this to defensive security. And after that brief introduction, we'll focus on basically the one graph database which is most frequently used, Neo4j. And if we have the time, we will also mention things about OrientDB. We're not sure we'll make it because it's well, sticking to the time allocated will be a bit tricky. We'll see brute force attacks, we'll see DOS attacks, how to create ransomware, anonymity, hidden channels, data leaks of all sorts. We'll go into more detailed things later on, and we'll have to think how to deal with this, because they're quite sensitive. And after that, we will release, well, it's been released already, an auditing tool called GraphScan, or we'll give you a link so that you can download it and play around with it. So, we'll start. Why graph databases? I wonder if you've come across this type of research, but in recent times, basically during the last year, we've made quite an effort to try and understand how these algorithms work. Algorithms that focus on machine learning for defensive security. We've seen a number of attacks, but we would like to talk about the algorithms, how they work, and how they can be cheated. There are technologies to mislead about images in many different ways, and there is a huge amount of interest in lots of technologies. All of them are really cool. Technologies to process huge volumes of information so that you can extract intelligence from it. Information is power. Well, that's a lie, because anyone with access to Google would be powerful, and that is not the case. What is really powerful is intelligence. And that's why large organizations, large institutions, and companies, and intelligence agencies use all sorts of technologies to try and correlate data and establish relationships that allow them to extract useful intelligence. Intelligence that does give power. This would justify an entire talk, but anyway, we're focusing on just one thing, just one very specific type of technology, which is graph databases. Why graph databases? Well, because these databases allow you to store information in a graph. We'll see about it later. We'll show what it means when we say a graph. And the good thing about these technologies is that they allow us to play around with relationships, and that gives us added information on lots of things. In cybersecurity, you can do cyber intelligence, you can do fraud detection, many other things. There's not too many comparison charts on what the best technologies are. This is one of the very few that you can find. And in that chart, you can see that out of the two technologies, the most important one is Neo4j and OrientDB. For that reason, we have focused on the main one. And then OrientDB, I think both of them account for some 80%. Yes, 80% between the two of them. There's lots of attacks to all sorts of analytics and machine learning systems, but we'll see about that in a later talk. Before Miguel comes in and jumps straight into the databases, before we define what a graph database is, we wanted to show you a video so that you can see what you can do with this type of databases with something as common as Wikipedia. Can you commute to video? I wonder if you know this project. This is a representation of Wikipedia in a graph. We were excited about showing this in a huge screen. Wow, it's a cinema screen all for us. As you see, the power comes through the relationship between entities. News from Wikipedia always give you references, and you see how the links are established. There are different sizes if you connect to the internet. This is very resource consuming. Well, this is a graph with vertices and nodes. Here, Wikipedia is represented as if it were a galaxy. We will not have time later on, but this is beautiful. This is so cool. It goes on for another 1.5 minutes. Anyway, we'll revert to the main topic. Neo4j. You need a technology, obviously, that allows you to store information as graphs, relationships and entities. Neo4j gives you that functionality. It will be Neo4j and OrientDB. This is open source. There is a large active community, and it is natively based on nodes and relationships. And it's got other characteristics like labels. You can have properties inside the relationship, so it's very powerful. It's then very easy to look for information. It is heavily implemented in a large number of companies. A lot of money has been invested on it. You cannot use the free version for production environments, but for startups can use it freely. And there's different open source systems or open source projects where you can upload your use case and see if you can apply graph charts or graph approaches to anything you want. What is so powerful? The query language, Cipher. In order to match a node, use brackets. Relationships are square brackets. In a very simple way, you can search for information within the graph visually, and you learn very quickly. This is an open source project, OpenCipher, so that anyone can use it. Companies are not too willing to do this that way because they'll end up having to resort to Neo4j, but it's quite an interesting approach. Anyway, there's different modes for the shortest route. You can use it directly this way. But the interesting thing is the security and the configuration. I mean, this is a hacking conference, so that's why we're talking about it. It's been evolving, different releases. At first, it was a pseudo-SQL thing, but then they created it from scratch with nodes and relationships stored in the corresponding places, but without security. You could connect freely, you could do whatever, there was no authentication. In DEFCON 21, there is a proof of concept in GitHub where they open a shell. It opens a shell. Oh, that was fixed in 2016 with the latest release at that time, with authentication based on basic HTTP. If you're in the same network, you can see the credentials. They used a more user-friendly browser, by the way. You see how it has evolved to become something that is much more pleasant. At first, it was much more technical. It was like a user administration interface, but now it's much more focused on business. They've added the HTTPS port, which is a good thing, although you have to install the certificates yourself. And they open a remote shell for Cypher to do queries that has no authentication, but in the tests we have conducted, we have found none open, because that port is not enabled by default. So people are wise and they don't bring it up. In the new release, which was launched in London during Graph Connect, new functionalities were added, but they didn't do anything about security. It was just a basic thing. And it was not until the very end of that year that they implemented user management. You can create more than one user from that version on, because you only had Neo4j and that was it. The good thing is that the password you need to change the first time you get into the system. We'll see what problems we have found. There is a version, there's something in version 3 where they disable HTTP and then they bring it up again. I don't know why. If you could speed up, please. And other services were added. That release gets rid of one endpoint. You don't need to be authenticated to see what version you're dealing with. And the licensing, quite interesting. There's no logs of queries, which is a problem. But the most important thing about this is that authentication is enabled by default, and it is not exposed to the internet. When you install it and start it, it is localhost. It cannot go to other computers. This is a typical situation throughout the world. We have something like 33,000 IPs that could be Neo4j, but Mascan and ZMAP are not ready for this type of services, so they give you a response even if it doesn't exist. They give you a response, but it doesn't mean that they exist. So in total, we believe that there would be something like 1,300. And you would say, what the heck? If it's not enabled by default, if it's not exposed to the internet, how come? Well, in some cases, they've exposed them to the internet, but they've used passwords. I'm connecting from home, no one knows my password, nothing should happen. Well, as we saw, the system is Neo4j by default if you haven't changed it, in both cases, user and password. If you get in, it means it's empty, because there's two restrictions for the password. One, that you don't use Neo4j as a password, and the second requirement is that it has at least one character. There's no limit to the string, okay? It is a good idea to a certain extent, because we believe that could be exploited. If I make a much longer password, it will take it. You can have a password for up to 20,000 characters. Neo4j will not respond, but we'll have to see how to exploit that. We haven't been able to exploit it because it's not an easy task. This is the configuration. If I want to expose it to the internet, that's what they do. Authentication is stored in the auth file. 256, which is not ideal. But anyway, if you delete the file, a new password is generated. End of story. What happens if you try to apply brute force? I know that the user is Neo4j. If it's Neo4j, I only need to use one thing, which is password. But it's got a system to block you and give you 5 seconds delay, so you don't keep crushing the system with password attempts. It does it per IP, so there's different attacks. You can wait every 5 seconds, that's very slow, or you can use open proxy lists that allow you to send requests changing your IP every time. So no 5-second delay in that case. an additional functionality of the mechanism in place against brute force. I mean, going per IP is very easy, but there is a flaw in the design in this database. It allows you to send the key that you want to use to authenticate. And if you're right in the same request, you could use the new key. What does that mean? It means that you could send requests and change the key without getting a response. So I could try a key or a password. If it works, I will just go for a default password, whatever it is, in attack number 3. So if I don't need to wait for a response, if an attacker had access to systems for which they don't need a response, I don't know, they're hacking a device, in an IoT device, to just send requests. Well, we could amplify the attack precisely because of that incorrect validation per IP. That validation changing the password is not properly carried out. The correct way to do this is that you authenticate yourself, you get a response, and then you send a new request for the new password. If you do this that way, you are implementing that response. You could do it using Tor or whatever. These attacks have been implemented in the tool. We'll see it at the end of the talk. It is a way to automate and go through the barriers, the security barriers. In the demo we're about to see, you see the code that was published in GitHub. You take the proxy list, you configure it to launch a request per proxy using different IPs every time. So it accesses using Neo4j, and creates a new one. The attacker says, okay, I'm going to attack using this dictionary. It's a very silly example, but when we tested it in the real world, it worked. We just didn't want to go from one IP to another. In this case, we did a study with 5 proxies. 5 proxies is enough. When they block you for a certain IP, they don't remember what IP you were banned at. So you don't need to have a long list of proxies. And now we have the demo itself. People never cease to amaze us. You may not be exposed to the internet and you may have authentication disabled. But people are also, they give you security, but then you get rid of it. You get rid of security. And you give full access to the database with all the permissions because there's only one user who is an administrator. Here you don't even have a user. Okay? Now Alfonso will tell you what can be done to resolve this problem. At the end of the day, this is a typical problem on flawed design and security, on whether technology can be safe or not, but we always have humans behind the scenes and we don't manage risks too well. At the top you see the typical stuff. When we started testing the security for this type of databases, well, you look around to see what people are doing. When we first did this capture, there were some 300 databases without authentication. Someone has edited the configuration file and said, okay, I'm publishing it in the internet because I want it to be stolen from me. That was the idea. Configuration files, as you see them. So this is malpractice in configuration, a problem that has a big impact on everything we do, as we will show in a few examples later on. There is a note here on all of these databases. We have the relationship between the 2 releases, community and enterprise. As Miguel said before, the main difference between the community and the enterprise releases is that the enterprise release implements some additional security measures, for example, logs, to log queries, amongst other things. But the enterprise edition is very, very expensive. Here you may have an idea. Why do people use the community version? Because it's cheap. Well, it's free. The community version is being used by companies that should be using the enterprise version. If Neo4j wants to make money, well, they should go to the internet and find out who is using the community version when they should be using the other one. If they pick on us, I would remind them that they really need to look farther beyond. A disclaimer at this point. Most of the time on this presentation has been reporting cases how to minimize the impact of everything happening in the internet, because there's lots of things. What we're about to show you now has been reported. Some people may have not closed it because they just didn't feel like it, but we reported about this months ago. There's lots of data that has been anonymized. We just want you to get a flavor of what goes on, at least in this example. We'll see others. But at the end of the day, we like this technology and we would like to see it improve. So let us hope that no one gets too angry.
And now, very quickly, we'll show you examples, some about someone in a faraway country found. I'll go fast. So we have two different versions. We give it colors. We've got lots and lots of information. So I didn't mention. So if you look at that in detail, what can you copy? Well, you could copy sensitive information. And when I say sensitive information, I'm talking about hundreds of thousands of emails, keys to access remote service, telephones, hundreds of thousands, research data, research databases. So in general, data. And of course, there are some minor databases, not important databases, but some data are very sensitive. And we'd like to give you a more specific example and to show you names. Okay, don't get frightened. Everything is under control. Okay, examples. What is the problem with this database? Logically, someone could take your database, analyze your data, and see what's in there. But when you detect that one of these databases is open on an IP, open IP, then you could go to port 80, where you would have both database and websites, and then you could interact. Do not think about modifying data only. We'll see other attacks later on. You can do many things. So couple of interesting examples. So for instance, this website recommended you a movie, so the database was fully exposed and we could play around with it. So this is amazing. So companies who do that do analytics and they are not protecting their own databases. Oh, this one I love. It is a streaming platform to learn the Bible. So 2 rooted ago, when we were talking about malware in Android, I don't know whether you remember that I shared a case of a Turkish person exchanging recipes about marijuana in Turkey, and he also talked about Quran. So this is recurrent. I don't know why. Well, these people seem to be cool, and then you connect it there, and then you get to see Gospel of St. Paul's, whatever. So these here there are security issues that perhaps I just don't want to discuss. And then in terms of databases for apps shared by friends, instead of doing nonsense with your friends, you just download the full database, and then well, it is easier to find the girls. So there are many cases out there, many sensitive ones, and we had a couple of them that were highly sensitive. This being one of them. We refer to it as the car dealership case. We are not going to give you lots of details about it, but we'd like to give you some food for thought. Basically, this case is about companies, public algorithms. This is a database that we found when we were profiling. We found it 9 months ago when during research, we scanned the internet to see what was open, primarily to report it. We wanted to report any sensitive cases in Spain. This case was found in March last year. So when you connect through Near4j, it gives you some labels back. And that information could remind you of a car dealer. Imagine what car dealers are like. We left the database for a few months, for 4 months. We didn't do anything with it, and then in summertime we went back to it because we were surprised. We had doubts, and I said, well, I don't think we are so cool in Spain. And then we went back to the database, and what we found was a bit heavy stuff. We reported it to the civil guards. I would like to thank Cesar. He fixed the problem fast. And I'm showing you this case just for you to reflect shortly about all these aspects that are so trendy about analytics, transferring data to third party. If you do analytics, the security of your equipment are the same as any other security, because perhaps those analytic equipment require some security as well. So this database did not have any authentication on purpose, and it was exposed on the internet on purpose. So there is a malpractice here, to put it softly. And also, these machines, if there is someone with ill intentions, could be easily hacked. We ruled it out a year ago because the security of that machine was so bad that it made me think that was honeypots. So someone with ill intentions, after dumping this database on the internet, could have crashed that machine and gain access to the network. So what I mean is that if you are doing interesting or important things with the internet, be careful of sensitive information. And here we don't have authentication, but it is not only about consulting data, so we prefer to do more interesting things. And the first thing that comes to mind, why has it been disabled? Well, some connectors are likely to do that because they didn't decided to have any other type of authentication, and they decided that it's better if you disable it. However, but the good thing is that with the actual cipher, you can not only consult information, you edit it, you dump it, you delete it, but there are also other things that you can do with it. For instance, cover channel, inserting information without impacting the drive, so that someone else connects afterwards and reads it. So we will show you injection attacks examples. In the end, we created our auditing tool, and that tool we wanted to be similar to SQL map, that is to say, tools for databases with specific languages. These are examples. Perhaps you are not very familiarized with it. So sentences in this language allowing you to dump databases. So as Miguel said, if I have access to a database, the most important thing for me is not only stealing information, because I can do many things in database. Database may allow me to crash down the machine or the network or ransomware. And I could also amplify a denial of service attacks if you are not careful with that. So what I say, it is people use community. Therefore, it is very important that you introduce security into community and not that very much, not in enterprise, which is not that much used. So when you think about editing information, you go and say, well, someone with the role of analyst, I'm going to give it the role of admin. And then you will be able to access the system. But however, there were other nicer cases, for instance, in terms of products, where you could change the price of the product, where you could lower the price of the product. In case of NEAR, the 400 that are open, but however, there are nearly 1,000 that are not open. And well, if you had a small dictionary, you could extract information from there. Imagine the most classical model, the database in SQL. You can change prices. You can do very many things. So without authentication, you can access to some elements of the browser. And interesting enough is that you may use their API to consult their own API to see their data, whether you are authenticated or not. If you edit a password, they don't let you do it, but if you insert a URL, you are generating traffic. And we don't understand why that happens. And actually, if your intention is not only stealing information, but using the machine to amplify attacks, there are design flaws where you can send out a request to the database and doing it through that. So in this case, I don't know whether you can make loops where we can send a query, but that is not a mystery. So the idea would be to send a request so that and asking to do that 1,000 times. So it is doing something that it often doesn't. Well, we can also ask it to send out spam outside. Also, denial of service. In Neo4j, waits as long as needed to give you a response back. So you can ask it to create a large number of nodes to introduce them in the database. You may overflow the RAM memory. Sometimes the machine is crashed down. And the thing is that, okay, well, you change the timeouts, but if you do that, you may be denying yourself because some requests are very lengthy, and if you disable the timeouts, you won't have time to send your queries. So in this demo, this may look a bit strange, but here you will see us making a number of requests. I'm going to create as many indexes as possible in the database. Indexes will allow us to consult the database. However, they are very large, and the drive gets easily full. Then it also allows you to upload information from the outside. So you may go and say, charge this CVS from the internet and import it to the database. I found one of several gigabytes, and then when you launch the requests, you just don't have to wait. So after the second, if you don't get any response, to stop it because the servers continue to run, and then it starts to import data. And the good thing is that when you create so very many nodes, then you crash down the machine completely. So here you see it on the left. It is very difficult to show you because you are both victim and attacker. And if I did it on the machine, I could not make the recording, and I couldn't do actual denial of service to real equipment because I was not interested in that. So everything will be uploaded to GitHub. So for you to have a feel, the attacks in the tool for RAM memory and for the drive. So if you can inject traffic, so actually it only requests a couple of queries to crash down the server. So if you can inject 2 requests, we do denial, and then we crash down the server, because the database would end up taking up all the memory or all the storage capacity. So let us talk about ransom. Please do not get anxious about it. Well, how does it work? We more or less are aware of it. And in the last months, it's been trendy to infect databases because this is a cheap thing to do. Well, you find a database with no keys, you connect, you dump database, you encrypt it. Therefore, it is relatively easy to infect many machines with ransomware. Miko used this slide yesterday. This is a typical current ransomware map, and we wanted to look at that in Neo. So imagine that an attacker manages or succeeds in injecting requests. What could he do? Well, if someone can send requests, I can export the database, I cipher it, and then I import it. And then after that, you pay. However, if your database is of 40, 60 gigas, this is costly, and sometimes you feel lazy about that. And then we decided to create our own ransom. So let me tell you that we will not be releasing the code. It is not in the tool. We will not be publishing it. We'll just play a video for you to see how it works. But this is just for you to take into account new features of database, how an attacker could use them, and then I will tell you how we could mitigate that. So we looked into the Cypher language, and we started to look for nice functions. There is a nice function. The name of it is replace. When you said, OK, take this one and replace it by this other thing. And what are the advantages here? Well, the calculation is made by the server and not by the client. So because the server calculates that, this is cool. Because if I can use it, I could make a ransom, and the database will cipher the information. Therefore, I will send out a query, and then I would left. And I don't care whether the database is 50 or 100 gigas. We are not going to tell you in greater detail how it works, because we don't want to give you lots of hints. So you need to have well-tuned cryptography. Then you go and say, replace this by that. And then it changes things for you. Additionally, there is also, we find what analysis systems have. That is to say, relationships. So this tells us how nodes relate to each other. So instead of ciphering data, what happens if I remove links? So this is a very easy ransom. I just delete the links. I just copy them, import them, and that's it. So we are going to relate them. So this is a video of a ransom. So in the demo, you see, well, we have our database in Neo. So this is very nice. The balls move. And then the secret machine will launch the ransom through the replace function, etc. So if this is a community, we will not be able to see what happens unless we pay. So all the links are broken, and the information is shown below, encrypted. So some things, for instance, the dates are not encrypted, but we just did it on purpose. So you see that all the relations have been deleted. Now we will send the reverse. So ciphering is fast. You send out 2 queries, and it does it for you. Recovering that is costly because you have to introduce the relations. But the attacker would only do that if they get the ransom. So you download the relations map, because it is not easy to find out the relationship between the nodes. But if you just send a query, you get that information, and then you read this database, and then you import each of these relations. That is to say, you create them. This is not difficult. It was harder for me to record the video. So for you to have a feel, well, we didn't test it in real life, but we believe that in between 5 and 10 minutes will be enough to cipher all the databases on the internet. That is to say, between 400 and 500 databases in 10 minutes. So, of course, you have to tune it, because you send out 2 queries to an IP, and the server does it for you, and then you channel that through Tor, or you name it, and that's it. And, of course, you need to know how to inject it, either through breaking authentication, if there is no authentication, or if it's empty, you don't do it, or also through connectors. But sometimes connectors do not allow you to inject. So this is what we wanted to tell you, all the basics that we wanted to tell you about Neo4j. Lots of work to be done. But after a year, we have gotten interesting results. So OrientDB is the large competitor of Neo4j. well, we just want to be friends with them, okay, because they are very much into legal claims, etc. So some companies are using it already. However, some of the things that in terms of security do not really make sense. This one has more than one CVE, and the version they are using is the one that we have downloaded. The thing is that they upgrade every 2 weeks. For whatever reason, they upgrade every 2 weeks. Okay, I just don't want to overdo it here. So how does it work? You create the OrientDB server, and contrary to NEO, you can create several instances in the database. How does it work? It asks you for a password, a root password, the first time you run it. You may either enter your root passwords or you just click enter, and it creates one for you. What is the problem? You may access as root even if you haven't used as a user before. So therefore, if you try it and you get the password, it allows you to access all the databases. Default port is 2480 HTTP. You have to set it up from scratch. I tried it. I couldn't do it. And there are also strange things. It creates a database by default known as Grateful Dead concerts. We are looking into how to exploit it from here. Every time you create a database, it does not generate a default user, but 3. So just in case you have an admin, a reader, and writer, and you can try the 3 of them to see whether if you have to delete the database every time you create it. And what is worst is the manual. There are some things in the manual that when you try to do them, you cannot do them because they do not happen. So the default users, it's very trivial, but it creates like 3 users by default. And for every database that you create, you have these 3 users. 3 users for every database. It gives you 3 default users. And there is a strange thing that it is not well documented in the manual. So that database is a good entry point to carry out injection attacks, trying to crash down the machine or to launch attacks outside. Contrary to Neo4j, well, often the security of Neo is better than that of DB, but we prefer Orient. We prefer Orient in terms of licenses. Orient also has a community and enterprise license, and the difference is about performance, escalation. In terms of security, they are very similar. So the product is as secure or as insecure as Neo. What is the problem that we often have? Well, what we are telling you is about the version that you may download from the internet. And the main problem is that there is a huge difference between what they say in writing and reality. There is kind of lack of coordination there. We'll give you an example. You may get any Orient database and to list all the databases without authentication. Why is that? Well, we just don't know. The documentation said that you need to authenticate yourself, but if you don't authenticate, you can list all databases. So if you have a user by default, you connect to it. And if not, as Miguel told you, root allows you to remote connectly. So you can do brute force attacks through that. So therefore, they make it very easy for you to list all the databases so that you select the one you can launch the attack to, and then they tell you about the different versions. So all these without authenticating yourself, just by reading and typing. Reading and typing. This is as much as you need to know how to do. So by default, OrientDB exposed to the internet, and that is not recommended in the documentation. What do you do? Well, you go to the countryside for a walk. There is nothing you can do about it. So perhaps this is the main reason, but we have found many cases of many highly respectable corporations because using it because they read, perhaps because they read the documentation and they believed it. So on the internet, where can we find these changes? But this is for you to have a field. Around 214 OrientDB servers. I don't know. Well, the difference with NEO is an OrientDB server may have more than one database, may have n databases. So actually 240, but we have some 553 databases. How do we know those figures? Well, despite you authenticating yourself or not, you can read and list all the databases. So versions, endless number of versions. This is chaos. I don't know how they manage the different versions. There are like some 100 versions. So this is a brief summary of what you find on the internet. Someone from a remote country could consult. For instance, out of those 533 databases, 188 have default credentials. Out of these 500 databases, this one, Grateful Dead concert. So the name comes from a rock group, rock band from the 80s. Well, I haven't heard about it before. So 104 are Grateful Dead concerts. So actually, the problem is that these documents are really poor. So if that database is open, you can make injection attacks. And there are other attacks that we are not going to share with you because we are validating it. Other attacks will allow you to escalate privileges and to become the root of the server. So we cannot show them to you because we are still seeing some failures. No protection against brute force logging attack. So that is a free-for-all. You can make as many attacks as you want. So this is about the Australian government. Miguel will tell you more about it. Yesterday I was a bit concerned because they are not they are ignoring us. We've been reporting cases for many months now, and they have not closed the system yet. So this is a nice case because it tells you about the test environments and the production environment. So if you have doubts as to whether to attack them or not, they tell you that all the environments are set up in the same place. And let us see what I can do. So the thing about creating your own cards, systems for equipment management, mobile apps, speaker, alarm systems through voice over the internet. Here we see like 5,000 personal details. Another one about artificial intelligence. So using these graphs is very trendy. We use it. And this is the Bible thing. Korean priest talking about Bible. Again, we see the same thing. I was following him on YouTube. And then, well, there is a parallel database. And to summarize, OrientDB summary. So in half of the cases, the database by default is not deleted. Well, I found cases where users were deleted, but the database was left there. You can make injections the same as NEO, but not in DB. Listing database, to me, that's a huge mistake. You can see whether it is production or not. You can tell it by the name. Then in the case of root, you can do brute force through root. And if you have access to it through any as a user, you may download the database only after sending a query, and then import it locally. Things about the information of the server. This is a brute force attack. The code is on top. It's very simple code. And then on the right, we can see that if you gain access to server information, you can see who has connected to the database, even if that is not your database. So you can see the clients who are using the database, the commands they use, the time they spend. So this is a tool. It's on GitHub. So we hope that you like it. It is the first time that we do it. This is a beta version. We will be adding other databases and other attacks. This is for you to start having this type of information. For instance, like if in a blue team or in a red team, you want to have a script to control security and to see how you can mitigate problems related to this technology. Well, this is there for you at your disposal. But the good thing about it that it is ready for you to create a reporting JSON. So it looks for Neo4j, and if it finds ORNTB, it gives you all the possible information.
So you have the labels, you may know whether it's important or not. Why do we investigate some and we don't investigate others? If you could go back for a second, a typical attack that gives you information, footprinting, and similar things. On authentication, you get everything. You got brute force attacks. You got DOS attacks. Nothing with ransomware, but you have all the others. You can tunnel it. You can tunnel the requests. That is integrated in the tool so you can do your tests. Don't be too wicked, but you can perform lots of tests. Conclusions. Oh, we're doing quite well in time. The talk we gave in order to prove that we like these technologies. We use them in internal projects, and we believe that they have a long future ahead of them. But obviously, you need to learn from mistakes in the past and not make them again, be it in default configurations, brute force protection based on IP address. I mean, that comes from the 90s. Password policies. I mean, this is 15 years old. Not sending queries to third parties, trying to work on mitigating injection attacks. If someone sends a denial query, how to manage time. It's complicated, but it can be done. We didn't want to be too flash with the things we're saying. If we had used brute force, we might have achieved 80%, but about 600 databases exposed everywhere. Public institutions, private organizations, organizational layouts, some banking things. There was a mixed bag, really, with a little bit of everything. We wanted to give you a figure in gigabytes, but we decided not to do it because when you connect, you get the information, but the data doesn't imply that you've got useful information. It could be 50 gigabytes, but perhaps you only have 3 gigabytes of useful details. So this is just to give you an idea of what we are talking about. With basic things, like reading the manual, and I'm distrusting what people may say, which should be enough. We will mention some basic things, some countermeasures, but allow us to think about a comment that was published recently by César. I guess that most of you know César, which has a lot to do with this world of ours, with our profession. We rely more and more on technology, but technology is less and less safe because development doesn't take place in accordance with best practices. Quality testing is not good enough. And when you do things in pen testing, well, these are the things you come across on a daily basis. These are just some basic recommendations. Obviously, the design flaws are things that you cannot avoid. You can mitigate at most, but do your best and try at least that people don't authenticate. Yes, you cannot prevent brute force attack because there are design flaws, but you can put technology around it. Or don't get rid of the technology, of the security technology that comes by default with Neo4j. The flaws that we mentioned, like listing the database, well, that's part of the design. There's nothing you can do about it. They'll have to think. So that was it from us. Contact details on the screen if you want to ask anything, now or whenever.
Tiempo bien. Bueno,
let me jump the queue again. Have you thought about correlating all the databases that you have found, like creating a database that would show graphs of the graphs that you have found and see what common attributes may be shared between the nodes to try and derive? Well, I'm losing my own drift. You know that I'm crazy about this. I don't know about Miguel, but in my view, we're reaching the limit here. What limit are you talking about, or what border? Well, we know each other. I think that would be a good thing, but we mustn't be too wicked, okay? I mean, this research, this investigation has been funny and amusing enough. People are more or less aware, but I don't know. To give you an honest answer, it's trivial. You use the range, download the labels. You do it in one afternoon. But correlating Neo4j or ORMDB with information behind, that is cool. If you correlate the information with the service, that's where you find the real problem. Questions from the floor? I don't see any hands. Okay. Down here, please. Have you ever tried to go to those websites where you may suspect that they have that database to do some SQL injection with this type of database? Well, I don't know if we made it clear. When we talked about injection attacks, there are applications that you can send cipher queries to the server. But those specific cases wouldn't allow you to launch the query from the client. The connection between the client and the server was correctly configured, but then the database was exposed, so they would attack the database directly. More questions? On Cesar's comment, in my opinion, what happens after 30 years of awareness, training, education, events, is that people are still not aware. We should impose penalties and sanctions on people that are careless. I mean, it's those people that have installed and configured their system in a really bad way. I think we should push for real penalties, severe penalties. I'm talking about prison sentences for exposing personal details, or penalties for up to millions of euros, things like that. Hit them on the head with a stick. I know, but it's complicated. Yes, I mean, people could get hold of information and kill someone because they've extracted their information from a database. Yes, I know, but a huge fine would imply that a company would go bust. Yeah, I know, but what happens when a doctor makes a big mistake? What happens when a doctor is drunk, goes to the hospital and is drunk, and someone dies at the operating theater? What happens when a sysadmin leaves data exposed? Should someone pay for that? Should someone be sent to jail for that? Let's leave it there. Questions? Okay, well, thank you very much indeed.